On behalf of Rohini College of Engineering and Technology, myself, Justin Leo, Assistant Professor, Department of Mechanical Engineering, welcome you all for this Basic Civil and Mechanical Engineering course video session. And the course code for this Basic Civil and Mechanical Engineering is BE8252, and for the regulation 2017. So in this video section, we'll be studying about mechanical engineering and its branches from Unit 1, Scope of Civil and Mechanical Engineering. So the objectives of studying this basic civil and mechanical engineering course is to impart basic knowledge on civil and mechanical engineering, and to familiarize the materials and measurements used in civil engineering, to provide the exposure on the fundamental elements of civil engineering structures, and to enable the students to distinguish the components and working principle of power plants units, internal combustion engines, and refrigeration and air conditioning system. So regarding this syllabus for this Unit 1, Scope of Civil and Mechanical Engineering, and the first part is overview of civil engineering, and the second part is overview of mechanical engineering, in which the students will be studying about mechanical engineering contributions to the welfare of society, specialized subdiscipline in mechanical engineering, production, automobile, energy engineering, interdisciplinary concepts in civil and mechanical engineering. So these are all the textbooks and reference books for this course, Basic Civil and Mechanical Engineering. So the course outcomes. So upon completion of this course, the students will be able to explain basic concepts of civil and mechanical engineering from Unit 1, and from Unit 2 the students will be able to select the materials and measurement techniques used in civil engineering, and from Unit 3 the students will be able to summarize the fundamental building components and the civil engineering structures, and from 4th unit the students will be able to illustrate various IC engines, that is internal combustion engines, and power plant systems and subsystems with layout. And upon completion of the course, the students will be able to experiment with the typical domestic refrigerator and different types of room air conditioner from Unit 5. So in this video section, mechanical engineering and its branches. So the first branch of mechanical engineering will be studying about the production engineering. So what is production engineering? It is a combination of manufacturing technology, engineering sciences with the management science. And a production engineer typically has a wide knowledge of engineering practices and is aware of management challenges related to production. And the goal is to accomplish the production process in the smoothest, most judicious, and most economic way. So in this branch, production engineering, so what would be the role of the production engineer? So the production engineer possesses a wide set of skills and also competences and attitudes. So all these are based on the market and the scientific knowledge. And these abilities are the fundamental for the performance of the coordinating and integrating professionals of multidisciplinary teams. So what would the production engineer would be able to do? So the production engineer should be able to scale and integrate resources, and usually required to consider the physical, human, and financial resources at high efficiency but at low cost. And the production engineer should also be able to make proper use of the knowledge of maths and statistics in order to model the production systems during decision-making process. And the production engineer also should be able to design, implement, and refine products, services, processes, and systems. So, taking in consideration that the required constraints and particularities of the related communities. And the production engineer also should be able to predict, and he should be able to analyze the demand, the design, redesign, or improve products service functionality. So the second branch of mechanical engineering is the automobile engineering. So considering this automobile engineering, it is a branch study of engineering which teaches manufacturing, designing mechanical mechanisms as well operations of automobiles. So it is nothing but an introduction to vehicle engineering, which deals with the motorcycles, cars, bus, trucks, aeroplanes, etc. And it also includes a branch study of mechanical, electronic, software, and safety elements. So some of the engineering attributes and disciplines which are much importance for the automotive engineer, and the aspects are being listed out as follows. So in that you have this safety engineering. So safety engineering is nothing but the assessment of various crash scenarios and their impact on the vehicle occupants. And some of the requirements usually include this seat belt and airbag functionality testing, and front and side impact testing, and tests of rollover resistance. So all this comes under the safety engineering. And the second attributes is the fuel economy and or emissions. So fuel economy is nothing but it is measured the fuel efficiency of the vehicle in miles per gallon or kilometers per liter. And this emission testing includes measurement of vehicle emissions, which includes hydrocarbons, nitrogen oxides, carbon dioxides, and carbon monoxides, and evaporative emissions. So all this comes under the emissions. And NVH engineering, that is one of the attributes, engineering attributes and discipline. So N stands for noise, and V stands for vibration, and H stands for harshness. So normally NVH is nothing but the feedback of the customer, that may be both tactile, that is felt by the customer, and audible, that is which is being heard by the customer from the vehicle. And you can see this sound can be interrupted as a rattle, squeal, or heart. A tactile response can be seat vibration or a buzz in the steering wheel. So all these are the indications. So this feedback is generated by components, either rubbing, vibrating, or rotating. And vehicle electronics. So automotive electronics is an increasingly important aspect of automotive engineering. So you all were aware of it. And you can see that modern vehicles usually employs lots of electronic systems. And these systems normally are responsible for operational controls like throttle, brake, and steering controls, and many comfort and convenience systems like HVAC and the infotainment and lighting systems. And it is also possible for automobiles to meet modern safety and fuel economy requirements without, and it won't be possible without this electronic controls. And next is the shift quality. So that is also an engineering attributes and discipline in automobile engineering. And this is nothing but it's a driver's perception of the vehicle to an automatic transmission shift event. So this is normally influenced by the powertrain, that is the engine transmission, and the vehicle, that is driveline, suspension engine, and powertrain mounts, etc. And the shift feel is also is both a tactile and audible response of the vehicle. And next is the durability and corrosion engineering. So durability and corrosion engineering is nothing but evaluating evaluation test of a vehicle for its useful life. And this test normally include mileage accumulation and severe driving conditions and corrosive salt baths, etc. And drivability, this is also an engineering attributes and disciplines, and it is the vehicle's response to general driving conditions. And next is the assembly feasibility. So it is easy to design a model which may be hard to assemble that would either result in damaged unit or poor tolerance. So the skilled product development engineer who works with the assembly manufacturing engineers in order that the resulting design is easy and cheap to make and assemble, as well as delivering appropriate functionality and appearance. So that is an important engineering attributes in automobile engineering. And next is the quality management, and this is also an engineering attributes in automobile engineering. So quality control, which is a very important factor within the production process, because you all know the high quality is required in order to satisfy the customer, and the customer would prefer a high quality product, and also to avoid expensive recall campaigns, etc. So when the quality is high, you need not go for recall campaigns, and which maybe cost more for the company. And the complexity of components involved in the production process would require a combination of different tools and techniques for quality control. So these are all the key points for this quality management and in automobile engineering. So the third branch of mechanical engineering is energy engineering, and it is also called as energy system engineering. And it is a broad field of engineering which deals with the energy efficiency, energy services, facility management, plant engineering, sustainable energy, environmental compliance, and renewable energy technologies. So energy engineering or energy system engineering is one of the more recent engineering discipline to emerge, and it usually combines knowledge from the field of physics, maths, and chemistry with economic and environmental engineering practices. So physics, maths, and chemistry is a key for this energy engineering. And energy engineers normally they apply their skills in order to increase the efficiency and also to further develop renewable sources of energy. And coming to the main job of energy engineers, it is to find the most efficient and sustainable ways to operate buildings and the manufacturing process. So in energy engineering, you have this power engineering, and this is considered a subdivision of energy engineering. So power engineering applies maths and physics to the movement and transfer of energy to work in a system. And next, in energy engineering, you have this energy efficiency. And this energy efficiency is normally seen in two ways. So the first view is that more work has to be done from the same amount of energy is being used. And the other perception is that the same amount of work is accomplished with less energy used in the system. And in order to get more work out of less energy, it is to reduce, reuse, and recycle the materials normally used in daily life. So with this, we come to an end with this video session of the first unit, the branches of mechanical engineering. So thank you and have a great day.